Good evening, students. In this session we are going to classify different materials based on their conductivity. This is just introduction part for unit 4, which is PN junction diode, filters, rectifiers and Zener diode. What we are going to do is we are going to classify different materials based on their conductivity. Moving on, the materials are classified into three types. The first one is a conductor, second one is an insulator, and third one is a semiconductor. So now what is a conductor? Conductor is nothing but a material which allows the electricity to flow through it. Simply, example for conductors are copper, gold, silver, etc. So now here is the question arise. Now what makes the conductor to conduct electricity? So in a conductor there are excess free electrons in the outermost orbit. Suppose for an example, take a copper. In a copper there will be a nucleus and a 1s orbit, and there will be a 2s orbit and 2p and so on. In the final outermost orbit there are excess 2 electrons which are weakly bound to the nucleus. So these excess 2 electrons which are not closely bound to the nucleus are reason for the electrical conductivity. So these electrons will allow the current, will carry the charge, allow the current to flow. Similarly in a gold and in a silver and in a copper. This is with the conductors. And coming to the insulators, it is completely opposite with the conductors. What happens in an insulator is, take a particular atom, the outermost orbit will not have any excess electrons. So every electron is busy, which means every electron is paired with other atom's electron or the electron which is present in the atom itself. So in an insulator there is no free electron, so there is no chance for electrical conductivity. So such materials where there is no free electrons and there is no chance for electric conductivity is called as an insulator. The example for insulators are paper, rubber and plastics, etc. This is with the insulator and a conductor. Now what we learned, a conductor is a material which simply conducts electricity. The reason for electrical conductivity is nothing but free electrons in the outermost orbit. Similarly for an insulator, the reason for it being an insulator is there are no free excess electrons in the outermost orbit, so it will be as an insulator. Now coming to the important material, which is a semiconductor. Now semiconductor is a special type of material. What does it does is, it behaves as a conductor or as an insulator depending upon the conditions. We are going to talk about what are the conditions later. So for now just remember that semiconductor is a conductor and as well as an insulator. The example for semiconducting material is silicon, germanium, etc. A pure silicon material can be a semiconductor. A pure germanium material is a semiconductor. We are going to discuss what are the conditions to make the semiconductor a conductor and what are the conditions to make the semiconductor an insulator. So moving on to the types of semiconductors. So semiconductors are classified into two types. One is an intrinsic semiconductor, other one is an extrinsic semiconductor. Now coming to the intrinsic semiconductor. Now what is an intrinsic semiconductor? Intrinsic semiconductor is also called as a pure semiconductor. Now what happens in intrinsic semiconductor is, how to make an intrinsic semiconductor is, we are going to take a pure silicon material. Each and every atom is a silicon, and if we look under a microscope, it will be in this particular crystal structure. So if you take the electronic configuration of silicon atom, the silicon atom electronic configuration will be 1s2, 2s2, 2p, 6, and so on, and the final outermost orbit will have a 4 valency electron in a silicon or in a germanium atom. So in a silicon there are 4 excess electrons in each and every silicon. So if we consider these silicon, it has a 4 excess electrons. These one of the electron will make a covalent bond with the other electron. This is nothing but a covalent bond, and in similar way the other electron will make a covalent bond with the other silicon atom, and these electron will make covalent bond with these silicon atom. In this particular way, every silicon atom has 4 excess electrons in the outermost orbit, and every silicon will make 4 covalent bond with the adjacent silicon atom. This is nothing but an intrinsic semiconductor. If you see, in an intrinsic semiconductor there are no excess electrons or holes present in this intrinsic semiconductor. So what we can say, intrinsic semiconductor is a pure insulator? No, there is a condition for that. What is the condition is that if the intrinsic semiconductor, suppose a silicon or it can be a germanium, if we take an intrinsic semiconductor silicon, if the temperature if the silicon is kept at temperature 0 degrees Kelvin, so then there is no energy given to this particular intrinsic semiconducting material. So the silicon material will behave as a pure insulator which will not conduct any electricity. Now what happens if I increase the temperature greater than 0 Kelvin? Now what happens if I increase the temperature for the same silicon material, same pure silicon material, also called as intrinsic semiconductor? What happens? So these increase in temperature will be enough, this temperature will be enough to break these covalent bonds. Not every bond will be broken, few bonds which are closer to the surface or in this particular one, few bonds will be broken. So this will result in 2 free electrons. If a particular this bond is broken, these 2 will be free, electrons will be free, so they can roam free. So in this type of condition where a temperature is greater than 0 Kelvin or greater than particular threshold value, so these intrinsic semiconductor will behave as a conductor. Okay, clear with that? We have less time. Intrinsic semiconductor will behave as a insulator and a conductor. So example for this intrinsic semiconducting material is a pure silicon crystal or a pure germanium crystal. Now intrinsic semiconductor is a material in conclusion, intrinsic semiconductor will behave as a pure insulator at T equal to 0 degrees Kelvin, and the same intrinsic semiconductor will behave as a pure conductor at T greater than 0 Kelvin.